Welcome to this walk talk mock for J277 GCSE Computer Science by OCR, and this is a second paper called Comp 2. This paper is called Computational Thinking, Algorithms and Programming. So the front page is quite similar to what we saw last time, and we know that in the exam we're not allowed to use a calculator. The paper is worth 80 marks, and you get an hour and a half, so you get 90 minutes and it's 80 marks. So essentially you've got 10 minutes spare if you think about a minute per mark. Front cover is pretty self-explanatory. I'm going to talk through how do we answer these questions and how do we approach them as computer science teachers. Now, myself and my colleague, we run a website called www.smashyourexams.com, which is exactly that. We help you in computer science and other subjects to help you get to the grades that you need to get on to the next step. So please visit that website because lots of opportunities for tutoring and other things available on there. So the first question says we've got to spend 50 minutes on the first part. So component 2, unlike component 1, actually has 2 parts to it. What we need to do is 50 minutes in this section, and then we have a bit of time in the second section, which is mainly programming. So complete the truth table of figure 1 for the Boolean statement P equals not A and B. Okay, so what that means is that the input A and the input B goes into a logic gate, and then that answer is then reversed by a NOT gate to give you the answer. So we'd have to know a little bit about an AND gate. An AND gate only gives a 1 in the output if both the inputs are a 1. However, in this case, where both the inputs are 1, we get a 1 on the output, but this is reversed by the NOT gate. So we're going to have a go at this question and see how far we can get with this. So let's pick on these, type text. I'm going to put in here the fact that we've got 0 and 1. Now 0 and 1 would actually give us a 0, but because it goes to a NOT gate, that's going to give us a 1. Same this one, 1 and 0. The AND gate is going to give us a 0, but it's reversed by a NOT gate to give us a 1. That's question 1 done. Please tick one box to identify the correct logic diagram for P equals not A and B. Well, whether it's drawn a diagram or whether it's actually answering a question about a diagram, we always do what's in the brackets first. So we need one that's got an AND gate in. So this one can't be because it doesn't have an AND gate. So it's either this one or this one. Now, it does the bit in the brackets first. We'll expect the AND gate to come first. Oh, look, there's the AND gate first. And then secondly, the thing outside the brackets will come second, the NOT gate. So that one is actually this question here. So this is A and B going to an AND gate. And whatever comes out of that is reversed by a NOT gate. So that's that one done. Next one, a program needs to perform the following task. Input 2 numbers from the user, compare both numbers and output the largest of the numbers. So now nicely enough, the exam board's actually given us how to take the first bit anyway. So we're going to input, enter a first number. Now if you are, your school does Python, you would probably put int in front because you've been taught in your high level language that you use int and then input. So let's do that because a lot of you as students will be using Python in your schools anyway. We then need something here, 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 here. Well, if we want to compare two things, then what we do is we use an if statement. So if num1 is bigger than something, well, we haven't got anything on that side. So on this side, if num1 is bigger than num2, then do something. Well, if num1 is bigger than num2, then num1 is the biggest number. So we use a print command. Number 1 is bigger than number 2. I've changed the word bigger because it does say in the question the largest. Okay, otherwise print but 2 is the largest number. Okay, that's done. All right, let's check that back. Input 2 numbers, done that. Compare the 2 numbers, done that. Does it give print commands? Yep. Is that right? Number 1 is bigger than number 2. So check the crocodile the right way around. Yep. Print number 1 is larger than number 2. Otherwise, print number 2 is larger than the larger number. Yep, fill all the boxes in. I've left any blanks. A second program needs to perform the following tasks. Input a number from the user, double the number, and print the result. Repeat bullet points 1 and 2 until the user enters a number less than 0. Right, when we think about these kind of questions, the way we teach our students is to think about what inputs does the program need, what outputs does the program need, is there any processes, right? Does it need a for, an if, or while in the code? So it's a bit harder for me to do obviously on a computer, but this is an input. Okay, it's got to print the result. That's an output. Does that have any processes? It does. You need to double the number each time. Now again, because I'm on the computer, it's a bit messy, but you would do that nice and neatly to put there. Okay, it needs to repeat bullet points 1 and 2 until the user enters a number less than 0. Now is that a for loop, an if, or a while? Well, an if would only do it once, so that won't repeat. Now I know repeat, another word for repeat in computer science is iteration. So it could be a for or a while. And I've got to keep doing it until the number is less than 0. Well, they're entering a number, so it's actually going to be a while loop. And you might, in the exam, probably useful, have some different colour pens to do that as well. Okay, so let's try and write this. I'm going to leave a little bit of space at the top, just in case I accidentally miss anything out. So I first need to take in a number. So num equals int input. Please enter a number. And again, I'm going to use a little bit of metacognition and go along. I've done that one, haven't I? So what I can do is I can go and tick that. That's it. Yeah, I've done that. Double the number input and print the result. Okay, so I need to write some code that's going to double the number. It's going to add to this actually. Next line. So I don't know. Total equals num star for multiply by 2. It's got a bit. It's a bit big because it's a bit on the small side. Probably to read from where you are. There you go. We can read that nice and clear now. Number 2. I've done that. It's got to repeat until the user enters a number less than 0. Oh, but hold on. I haven't put the print in. So print. Now I need to have some meaningful output. I could. You'll probably think just put total, but that's not very meaningful. Just putting the total on the screen is not very useful. So what I'm going to do is going to put speech marks and put a useful message in. The number doubled is, and then use a comma, unless the question says use string concatenation, which it doesn't, and we can do that. Yeah, print the number doubled is, and it's going to print out total for us. But it says it's got to repeat this until get the end. So to repeat it again and again, we'll need a little while loop. So while the number, keep doing this until it is less than 0. So while the number is greater than 0, we're going to do this code here. Now we do have to indent this. So the exam board will mark us down if we don't. So we're getting there now. We've got input a number from the user. Yeah. Does it double the number and output the result? It does. Does it repeat bullet points 1 and 2 until the user enters a number less than 0? Yes, it does. I'm just going to put at the top here because num doesn't exist. At the start, set number to something that's going to make the loop at least go in the first time. Yeah. Okay. Let's just put it at 1 because 1's bigger than 0, so at least it'll start the loop. Now it doesn't say in the question whether I should tell them that eventually they didn't put the right number in. So let's just put a print command because we know that once that loop's finished, they've entered a number less than 0. You entered a number less than 0. But the key things we're going to get marked for here are we initializing variables at the start. 1, loop, and actually has the right number. 2, probably 3 actually. Input 4, 5. There's plenty of things I can get marks for. This bit's a just in case because we haven't been told how many things we can write. So it's probably worth putting it in as a just in case and how we do that. Right, question done. There's a database. The database table is called results. I'm going to underline that. It's quite important. So I know what the table's called, and it's got a capital R as well. So I need to use that capital R. Yeah, so I'm going to use that. That word's quite important. So I'm going to keep that in there. Get a text box. So select something. Let's read the question again. The database table results stores the results for each student in each of their subjects. Complete SQL statement to return all of the fields. Now in SQL, all is star. So I'm going to put that in there. Drag that into the space, probably a bit better, a bit bigger. So select star, and it's saying from which table? Well, the table we've been told is results. Now notice it's got a capital R, so I'm going to use that in mine. So let's put that in the right place as well. And then lastly, it says where, okay, let's look, where the students are taking art. Now, which column has got that in? Because that's called the field. So the field's actually called subject. But I'm going to use, again, it's got a capital S here, so I'm going to make sure I use a capital S. Equals, now in SQL, you only put one equal sign, unlike Python. And in SQL, it has a single quote rather than a double quote for any string. So ART. And lastly, to end the command SQL, an SQL command has a semicolon at the end. So let's just put that on there. Let's just read this back again then. So just double check. Database core results. I've got to find everybody, all fields, so star for all fields from results. Done that. Where the subject equals art. There you go. 3 marks. Done. You can move on. A program creates usernames for a school. The first design of the program is shown in the flowchart below. So, okay, take someone's first name in, take someone's surname in, then this new variable called name equals the first 2 letters of their first name. Username is their first name as opposed to called now, even it's called the variable name, plus the first 2 letters of their surname. Then we've got to output their username. Start the process, state using the process in figure 2 the username of Rebecca Ellis. So to give us an example there for someone called Tom Ward, a bit further down, we need Rebecca Ellis. First 2 letters of their first name, R, E, B. Okay, and then it says, we've done that, first 2 letters of their first name, done that bit, plus the first 2 letters of their surname, so E, L. Just check that, first 3 of the first name, yep. Last one, yep, check the order, it's definitely the first name, then the surname. Yep, and there'll be a print command, but we don't have that, so it's rebel. Done. Okay, next question. The program design is updated to create, and I've got to read this carefully because it is say it's updated. The program design is updated to create usernames as follows. If the person is a teacher, their username is the last 3 letters of their surname and the first 2 letters of their first name. If the person's a student, their username is the first 3 letters of their first name and then the last 2. It's just basically reversing it, yeah? What would be the username of a teacher called Fred Biscuit? So just checking again, I need to just look at this part here. Okay, and then have a go at that. So their name's Fred Biscuit. It's, now in this case, it's the last 3 letters of their surname, U-I-T. So that's really important. Not the first few letters, the last 3 letters. And then the first 2 letters of their first name. F-R. Okay. So just check that. Teachers, last 3 letters of their surname, U-I-T. Yep. And then the first 2 letters of their first name. Yep, F-R. That's absolutely champion. So next one, write an algorithm for the updated program design shown in question 4. B part 1. Now I've still got the original algorithm, so I can't get rid of that. I need all of that in there as well. So let's just go down and ask their first name. Let's just check what variable they used. So first name. Again, I'm just checking the case as well. First name equals input. Type in your first name. I then need their surname. Check what the variable they use was called. It was called surname, all lowercase. Let's do that. Surname equals input. What is your surname? Should probably have a question mark for the one above us, really, shouldn't I? So I've done that. But now there's something about being a teacher. So let's ask them if they're a teacher or a student. I can either say student equals are you a student or teacher, whatever, you know. Teacher equals input. Are you a teacher? Question mark. Right, so that's going to have the new design in. I'm then going to have to do this part for students. However, I'm going to have to do something different for the teachers. So I need a little if statement that's going to work out if they're a teacher or not. So if teacher, I'm assuming they're going to put yes or no, equals yes. Then I'm going to do something about that, yeah? I'm going to put a comment in for now to let me know I have to come back to this. Add code for teacher. Again, obviously you can't do this in the exam, but I'll just remind myself. Obviously else, they're not a teacher, they're a student. Okay, so add code for student. Okay, let's go to the teacher then. So if they're a teacher, I need their username equals something, but I need to get the two parts. So I need to get the last 3 letters of their surname. So I want last equals surname, but I don't want the whole thing. So there's a couple of ways I can do this. I can use square brackets, if you know how to do that, and then put a colon and say I want the last 3, which is -3. Or the exam will actually have their own little inbuilt functions as part of the pseudocode, which you will be able to see in the J277 spec. So I can actually call something called write, pass it what it needs, which is the surname, as a parameter, and also pass it how many letters from the right hand side it needs, the last 3. Okay, first equals, now that's the start of it, so it's left. I need to pass it the variable for the first name, which is that, and I can pass it 2, and that will pass that across. So their username equals last, string concatenation plus symbol plus first. In this case, same kind of thing, I can use the same variable names. So last equals, let's read it again for student, it's the first 3 letters of their surname, so I'm going to actually way around. First equals left, because I want the first 3, I'm going to pass it the first name, and I want the 3, and then for the last name, I want the first 3 again, so it's still their surname, and I'm going to pass it. Let's check this back. So if they are a teacher, the red orange section here, I need to check the last 3 letters of their surname, done, and the first letters of their first name. So really, it is quite useful to go through and check that. Yeah, done that, and I've done that. And then on the student, I've got the first letters of their first name, I'm using left, that's right, yeah, and the last 2 of their surname, yeah. Now what a lot of people forget to do at this point is, we haven't got a print command. So we still need a print command, and in my case, actually, I've just forgot to put username in here as well. So you definitely need to go back to these kind of questions, because even me as an experienced teacher needs to just double check things as I go along. So first plus last, and I do need to print out what their username is. So again, it's meaningful. So print your username is, comma, and I need to print out their username. And I've just realised I've made a little syntax error that I've accidentally spelled this wrong. So print your username is, yeah, that looks good. So I just double check the back, all the things I've got in. I've took their input site before, good, and I've now got in for teacher, yeah, done that. I've checked if they're a teacher or not, yep, I've got the right format. I've constructed a little string for this. I've constructed a string for the right way of doing that, and I've printed it all out, okay? So I'm pretty much done at that point. Right, next one. A computer game is written a high-level language. State why computer needs translate. So yeah, needs translating as a computer doesn't understand a high-level language. Computers understand binary, which is machine code. So we're kind of basically explaining that, yeah? So it needs to translate that. So it needs translating as a computer doesn't understand a high-level language. Computers understand binary, which is machine code. And you could add there, like a compiler will do this, yeah? Okay. Either compiler and interpreter can translate the code. Describe 2 differences between how a compiler and interpreter translates the code. Okay, so firstly, get some right place. It's kind of, these questions are very two-sided, so I do need to give both sides. A compiler reads all of the code at once and gives all of the errors. An interpreter reads the code line by line and only gives the first error. In a way, I've actually put a few things in there, right? Next one, to compiler create an executable file. An interpreter does not create an executable file. The other things I could even mention as well, compiler produces optimized code. An interpreter does not produce optimized code. Okay, now obviously I only give 2, so I'd have to, again, like I said, the comp 1, if you watched that, if you haven't, there'll be a link at the end of the video just to go back and make sure we can kind of double check that. Okay, a program uses a file to store a list of words that can be used in the game. A sample of this data is shown in figure 3. So we've got 1, 2, 3, 4, 5, 6 things in this little file. Show the stages of a bubble sort. So the first thing is, what is a bubble sort? Well, the bubble sort is where we start at the left-hand side and we compile items in pairs. And as we go along the pairs, we decide if they're in the right order. So I'm literally going to write the list as the file as a little list. Bait, fright, victory. Now again, in exam you probably don't need to do this. I'm just writing it like this, so it makes it a little bit easier for me in a second. Okay, so I need to compare this item, which is the first position, and the second one. Are they in order? Well, no, they're not. So a little bit easier for me because I'm on a computer. I'm going to copy and paste that list on the next line, and I can swap them around. So I'm going to have bait, and after that I'm going to have crime. Now to show the example what I'm doing that, I'm just going to underline to show that's really obvious I have done that. No, I can't underline here, but you should really underline it if you can. Okay, so I'll do it like this way, I'll do it this way, but you should really kind of underline it to show the example what you've done that. Some people draw boxes around. Let's continue that on. I'm not going to do the lines every time, but you should do that on yours. So I've got that. Just going to copy and paste it down again. I've got that. So the computer has now done these two and now goes on these two. Is this and this in the way? Well, again, you might have to do A, B, C, D, blah, blah, blah. That's right. C does become before F, so that can stay. I don't have to show that changing, okay? Fright and victory. Well, F and V, they're in the right order. Now this one I've got to check up a little bit. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, L, P, Q. Okay, so they're definitely not in the right order, yeah? So I'm going to put that one and that one around. And again, I should underline it to show them two swap around. So N becomes before V. And then I know that V is after L. Now I'm going to put this on again another line. Obviously I should have underlined those other two on there. It's a bit hard on the computer. So put them again, and I know that victory is bigger than loose. Okay, now in a bubble sort, once it reaches the right hand side, which in a for loop's for I in range from 0 to length minus 2 actually, I need to go back to the start, because each time I've been swapping things around, and the bubble sort works by knowing if when it's been from the left to the right, called a pass, if nothing has been swapped, it's done, but we have. So I'm going to go back to the start again, okay? So A, B, yeah, C, D, E, F, G, H, I, J, K, L, M, N. So these two are not quite in the right order, yeah? So I'm going to have to put them down again, but swap them two around. Like that. Swap them two around, so L, M, N, so L, M, N, O, P. Right, put them two around. Check I haven't done my things in. And again, you should, in the example, underline it, sure that's happened. Alright, so that's been done there. Let's double check. A, B, C, D, E, F, G, H, I, J, K, L, M, N, or P, Q, or S, T, U, and V. I am done. Okay? It is worth also noting down sometimes when you get from the start to the end, because sometimes the next question is literally what is it. So when I get the start at the end, it's called a pass. So that's where the end of pass 1 is. And when I got the end the second time, it's pass 2. I don't have to do this question to be fair, but sometimes the next question is literally how many passes are done. Okay, next one. I need to find the word zebra. So in a binary search, it works by having 3 pointers: a lower bound, which starts here, an upper bound, which starts here, and a mid, which we work out as we go along. Okay, so we need to say that, yeah? Let's move this down. So originally, the lower bound always starts at 0. And the upper bound always starts at the length minus 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is the length, minus 1 is 8. And that's because in computers, the list starts at 0, 1, 2, 3, 4, 5, 6, 7, 8. So I need to work out the midpoint. So the midpoint is always the lower bound plus the upper bound slash slash 2. Now slash slash is interdivision, or gives you the quotient. So that means that any remainder is completely lost. So in my case, my mid is, and I could write this all out again, is 0 plus 8 slash slash 2, which is 4. So again, I'd probably underline that. That's what I'm looking for. My middle point is 4. So I'm going to see if 4 is zebra. So 0, 1, 2, 3, 4. No, I found orange. So found orange, but looking for zebra. Not finished yet. Okay? Now, if the thing you find is smaller than what you want, you change the lower bound to be what the mid was, add 1. If the thing you find is bigger than what you wanted, you change the upper bound to be the mid minus 1. So in this case, the thing we found is smaller than what we want. So the lower bound can stay the same. Sorry, it's going to move in a second. The mid, upper bound, and then the mid again. Okay, so in this case, the lower bound is going to be the mid, because the thing we found was zebra. Yeah, sorry, it was orange. That's smaller than what we want. So we need to make the lower bound to be the mid plus 1. The mid was 4. 4 plus 1 is 5. Now we don't have to write the full thing down every time. I can now just show it's 5 plus 8. Okay, slash slash 2. Well, 5 plus 8 is 13. Divided by 2 is 6.5. But I'll lose the 0.5. Okay? So just make sure that you, again, take a bit of time to double check, because why people lose the marks is they don't fully add it up. It's got, oh, that's the answer, yeah. So we were 1, 4, and we went up to 5. So 5 plus 8 is 13. Divide that by 2 is 6.5, but we lose that bit, yeah. So let's have it again. 0, 1, 2, 3, 4, 5, 6. We found 10. But we're looking for, we're not finished. Okay, now I'm probably going to start running out of space a bit here. So again, it's the thing we found, which was 10, is that smaller or bigger than what went to actually smaller again. So it's the same thing again. The lower bound is equal to the mid, that was 6. 6 plus 1 is 7. The upper bound is still equal to 8. And the mid is equal to 7 plus 8 divided by 2. Was 7 plus 8 is 15. Divided by 2 is 7.5. And again, I'm just going to double check that we get that right. So 7 plus 8, yep, that's definitely 15. Divided by 2, that's 7.5. Okay, so 7, 1, 2, 3, 4, 5, 6, oh, sorry, before when we found it was, 0, 1, 2, 3, 4, 5, 6, 7, yeah? So this time we found wind, not zebra, blah, blah, blah. So we're going to repeat the process again. I'm going to make it a little bit quicker. And just basically the lower bound becomes 8, the upper bound becomes 8, the mid is 8 plus 8 slash slash 2 equals 8. Let's try that. 0, 1, 2, 3, 4, 5, 6, 7, 8. We found zebra. We are done. Okay, quite a lot going on there and putting them bits in. What I often get students to do as well is, as they do each part, but it's totally up to you, I just kind of rule it off to say, look, I've done this bit. I'm just going to underline it. Again, it's been a bit hard here, but it's underline it as you're going along just to make sure that you kind of done the right things. All right, so go down then. Here's a program. The area of a circle is squared by pi r squared, which we know from maths. Pi in this case is 3.142 and r is the radius. Fair enough. A program is written to allow the user to enter the radius of a circle as a whole number, integer, between 1 and 30. Then calculate the output of the program. Output of the area of the circle. Explain using examples from the program 2 ways to improve the maintainability of code. Well, maintainability is good variable names. They seem alright, to be fair. The variable names are not that bad. They could have added comments. They haven't done that, so I could put that one down. They could have used indentation. They haven't used that, so I could put that down. They could have used comments on their code. And why is that helpful? This would help with the maintainability of the program, as it would help future programmers to understand what the program is doing. Again, let's drag that down a little bit. Okay, so they could use comments, 1 mark. Why is that useful? Okay, because if you look at the question, it says explain, so I can't just put 1 point down. Number 2, they could also have indented their code in key places, such as after the if and else statements. This makes it easier for any other programmers to be able to read the code and make amendments. Okay, drag that again to make sure it's in the right place. Okay, now again, you should take some time reading the sentences back as well. We're just doing it a little bit quicker so we can get through the whole paper in a reasonable amount of time. And give you time really to go and visit smashyourexams.com. Okay, identify 2 variables. They're things that, so a variable is an identifier. There's a couple of there. There's possibly one here, which holds one piece of data, refers to a memory location, and can change and run the program. Well, for sure, looking at this, radius does change. And also area definitely does change. Again, just make sure it's the same case, which it is. There you go. Just identify it. So there you go. If I went in the program, that could have been written as a constant. They could have wrote pi as a constant, but they didn't. 3.142, which is pi in this program. Give one reason, say why you have identified this item as a constant. I is a constant as it does not change during the running of the program. So that's what a constant is, an identifier for a memory location that does not change in the run of the program, and pi doesn't change. Okay, next question. Tick one box, so one each row. Identify whether each program has or has not been done. Well, a sequence is where you've got 2 or more lines together that don't use an if statement. There's 3 straight away, so that's definitely has been used. Selection is where we use an if statement or a case select. There's definitely an if statement there, so that has been done. Iterations, a for loop or a while loop. I can't see a for loop or a while loop, so that's not been used. Next question says an IDE. Give 2 features when an IDE using writing the program. Now again, on our website we've got some knowledge organised, and that does really clearly identify the features of an IDE when you do write the program, but also when you debug it. This one says writing the program. So I can't put some things down that would help you debug the program. It's got to be about writing the program. So 1, it will auto-complete code for you when you use libraries. Another good thing is it will highlight the keywords in the code. Now, it doesn't say I've got to explain them, so that's it done. Right, section B, we should spend 40 minutes on this section. So first one says, a teacher reaches the length of time students play games. Tick one box to identify the data type. Just one box in total, not one each row, just single box. So I need something that identifies the number of minutes that students are playing games. Well, a Boolean's no good because that's true or false. A string's no good because that's not a number. And it doesn't say in the question whether it wants it to store whole numbers or not. So in this case, really, you could probably expect that either of these would be valid. And the reason I'm going to put real is as they could keep the hours and minutes played on a game. Because the whole part could be the hours and the other part could be the minutes. So I've changed my mind on that one just because it doesn't really say if it's stored at minutes or hours. So if I put both in, that would be a real instead. The program should only allow values from 0 to 300, blah, blah, blah. Complete the program to output input, so invalid input if it does not meet the criteria. So if it's above 300, basically, yeah? So if the minutes is less than 0, now it wants us to put here an AND gate or an AND or an OR. Well, it can't be less than 0 and at the same time more than that, yeah? So that's going to be an OR. So if the minutes is less than 0, or the minutes is greater than 300, which is easy for me to write, like so. Now, okay. Then, the invalid input's done for us, print. So does it give invalid input? It does. If the minutes is less than 0 or the minutes is greater than 300, then print. Yep, we've done that one. Complete the test table. Normal things that should work invalid would have to be outside, so anything above 300. So let's put that down as like 500, it's definitely bigger. Or 0 would also be fine. Sorry, less than 0 would also be fine. Like -1, or even a piece of text. Boundary, that is on the boundary, so 300. Oh, now weirdly in the question there, they've put if the minutes is less than 0, which is -1, or, okay, so we have to change this slightly because we have to also include 300. It's good obviously to show you sometimes, even us make little mistakes as teachers. Check that out. We're just going to sort that out there. So the minutes is greater than 301. We'll change it to instead. Okay. Now, if we put in 300, because it says should only allow values from 0 inclusive, we're not going to get there's nothing to print because it doesn't say anything there. So no output as program only says invalid, should say valid. Right, now there isn't a valid bit in there, but we're putting 300 in. It says inclusive, should only allow values from 0 to 300. We've got exactly 300, so that shouldn't give any output, shouldn't give us any error when we run that code. Next one, we've got a little two-dimensional array, so it's getting quite tricky at this point. Data from 1 week, Monday to Friday, stored in a 2D array with the identifier mins played, that's its name. The following table shows part of this array containing 4 students. The teacher wants to output the number of minutes Dan, column index 3, played the computer game. So they're going to put 3, 2 in. Okay, so this is 0, this is 1, this is 2, this is 3. And total it's done that for us as well. Write a line of code to output the number of minutes that Stuart played on that day. So print the name, it's called mins played, square brackets, and we're doing x, y, another bracket. Okay, now x for Stuart is 0, and it's the minutes played on Friday is 4. Let's just double check that. 0 for Stuart, yep. 4 for Friday, yep, done. Next one, they've done it like this. They want a quicker way of doing this. So we need to write a more efficient version of this. So let's keep total, because we do need that. The teacher writes a program that add up and print out the total. So a more efficient way is to use a for loop, yeah? for I in range from 0 to the length of the list, which is called mins played. But because it does this, we need to put -1. But basically saying go from the start of this list to the end of this list and print it out. So we need to first work out the total. The total now equals, like what I did before, plus mins played. Again, this is quite a tricky concept. So again, we have tutoring available on Smash Your Exams if you need a bit more. We want to print out the all in column 2. Okay, so we're going to put in the 2 this bit, because that does stay the same. And we want to print out the different bits we're going down. So we're going to put I in there. Now it's quite useful sometimes in exams when you do the for loop to actually give it a different letter rather than I. I'm going to give it Y because it's going down the Y coordinate or not like that. And then I need a print command, don't I? So, but the print command's got to come outside of the loop, so it's got to come after to add them all up. So print, again, some meaningful output, the total was, comma, print out the total. Let's just check that back again. So we've still got total. Yeah, so we'll get a mark for that. We've got that still. We've done an efficient way, a loop. Yeah, we've done that. We've got to be able to print it out. We've done that. And we've added all of this up together. And it would do that. Now, I've just noticed something very little and minor. That's why it's important reading about your code. If you notice here, I've got 2 star things, brackets. So I need 2 end brackets. And that's it done. That's quite a kind of tricky question for GCSE students to do. So if you're in an exam, try to do the bits you can. Always what are the inputs, what's the outputs as a way forward of that one. So the next one, so the following program uses a condition control loop. It's got 2 variables, x and y. And we've got to fill a trace table. So we've got to show how this loop works over time. So we start off by saying that x is 15. And the next one is 0. Now at this point, the first time round, we're setting the variables up. There is no input. So we're going to look at the loop. While x is greater than 0, well it is, it's 15. Y equals y plus 1. Well, y was 0, so y is now 1. Okay. X equals x minus 1. Well, it's now 15, take away 1 is 14. Okay, so we've done them two. End the while loop. Well, we don't need to end the while loop. We've got no output, so we haven't got down the print command, so we can't print it. Go to the top of the loop. While x is less than 0. Well, it is. It's 14. Go at the loop. Y equals y plus 1. Well, y was 1. Y is now 2. Then do x equals x minus y. Well, it was originally 14. 14 take away 2 is 12. But we still haven't reached the end of the while because we've got the back at the top of the while loop while x is greater than 0. Well, it is. It's 12. So we're going to go back around the loop again. Y equals y plus 1. So y is now 3. X was 12. 12 take away 3 is 9. But we still haven't got to a print command yet. We're going to go back around the loop again. Is it greater than 0? It is. But now we're up to 4. 9 take away 4 is 5. We're going to go back around the loop again. Because x is still bigger than 0. 5 is bigger than 0. Now reached 5. X is what it was before, which is 5. Take away y, which is now 5, which is 0. Okay. While x is greater than 0, well, it's not. It's equal to 0. It's not actually less than that. So we can skip the while loop and go to the print command, print y. Well, y at this point is 5. And we are done. However, on more modern exams, they're starting to put line numbers in. So again, there's available opportunities on smashyourexams.com if you need a bit extra help. A teacher writes an algorithm. So here's some code. I'm not going to read this out to you. The algorithm needs testing to make sure that if the if-else works correctly, identify 2 different pieces of test data that can be used to test different outputs of the algorithm, given the output from the program for each piece. So we need to basically get some bits that do this print command and some bits that do that command. Okay? So while valid equals false, input some number, and if the name of the game is bigger than 0 and less than 20. Well, we're going to say, let's say game name is going to be equal to, I don't know, let's think that's bigger than 0, tiger, there you go. Tiger is bigger than 0, and it's less than that. So it's then going to run it through games played equals game name dot upper. So tiger's now going to be all capital letters, and it's going to print out a valid game name. So that's what the output is. So print valid game name. Again, I'm checking the case where it is identical. I'm going to have some other test data that will instead not do this bit, will do this bit. So I need to think of something that's either less than 0, which is pretty hard. You can't put a string that's less than 0, but it's less than 0 and less than 20. Sorry, it's greater than 0 and less than 20. Well, tiger met the other bit, so we need something that's bigger than 20. And I don't know what I can think of here. I should really put in speech marks there. I love Star Wars. It is the very best. Now I don't know exactly how long that is, but it looks to me like it's going to be longer than 21 space 2 3 4 5 6 space 7 8 9 10 11. Yeah, it's definitely bigger than 20. So that's going to definitely give us a bit. And the expected outcome for that one would be game name is not. Now, again, just reading the question carefully. It doesn't say use a print command. It just says what the output would be. So let's just tell them identically what the output should be. This is why, again, in exams, take your time reading the questions. Let's just check that. Identify 2 different pieces of test data. Yep, they're definitely different. To make sure, give the output from the program of each one. We'll have. Again, I'm just going to put that in speech marks. I think that's better to have in speech marks. Same there. And we're done. Okay, with 2 different test data. The first one's between 0 and 20. Tiger's more than 0, less than 20. This one is very long. It's bigger than 20, so that's going to give us the game names not allowed. Okay, the teacher asks students how long they're spending doing their homework. Students answer in minutes and hours. For example, 2 hours, 15 minutes. The teacher would like to create an algorithm that will display students' input in minutes only. Identify the input and output. Well, the input, the number of hours and minutes. Again, I'm just going to shift that because it keeps putting it not where I'm clicking. The number of hours and minutes is the input, and the output is the total time in minutes. Okay, done. A program was created to convert hours in minutes into total number of minutes. A teacher wants to create a subprogram, so that was called a procedure or function. Oh, I've got a function already for us. To perform the calculation. The program has been started, but it's not complete. Ask the number of hours, ask the number of minutes, file total equals something, print. Now, a function is a subprogram that does return a value. So in order to do its job, it needs things passing to it to do its job, yeah? So we've asked them to top the hours and minutes. So we're going to pass in hours and minutes. Okay? So they're going to get passed to that. So we're going to do the same up here. I'm going to call the name of the function, which we haven't given one. So let's give it a sensible name. I don't know. Let's just call it mins. So just make sure it doesn't got the same name as any of the parameters. Just double check it doesn't say what we have to call it. It doesn't, so that's fine. So we're going to get it to call mins, pass it the hours and the minutes, making sure it's in exactly the same order as well. Okay, it then needs to work that out. So to work that out, it's going to have to convert minutes, and again you can write this on more than one line. Minutes equals the hours multiplied by 60, and then minutes equals the minutes we've just had plus on the actual minutes that are passed in. I'm just going to change something there because that's got min. That's going to confuse the computer knowing that I've got the same variable name. Just double check they're different. Okay, so I've asked them, I've created a function by passing it across, and I've passed it to bits of data exactly that they are, same case. I've then got the name of a function called mins. I've passed it the 2 things it needs. Happy days. I'm going to shift that across. I've then indented that. The minutes equals hours times 60. Yep. And the minutes equal to minutes plus I'm making my life a lot harder than it needs to be. Let's just change it to total. Total, because that's going to clash with them variable names again. Let's read this back again. So always important that you read questions back lots of times to make sure you get exactly right. That bit's fine. That bit's fine. Total equals hours times 60. Total equals the hours, the total that was before, plus the minutes. That was harder work than it needs to be. And then lastly, I need to return that answer. So return the total that we've worked out. Right, let's just double check all this off. Have we created a subprogram? We have. Have we called the subprogram? We have, and it's already caught for us. Have we got variable names that don't clash now after the third attempt? Yay, we do. I need a smiley face for that. Got there after a little bit. Have we worked out the total of minutes? Well, we have by adding 60. Yep, we're there. So again, because yours take a little bit longer, you won't make any of the daft little mistakes that I did there. But it just shows we all do make mistakes, and we just need to take our time. If I made a mistake in the real exam with that, and I said hand wrote that out, I would probably then just ask for another piece of paper, and then just write on here, see extra paper. Okay, the following flowchart outputs a message depending on how long each person spent playing games. If they're bigger than 120, it's going to go to the yes part. So if it's greater than 120, it goes this way. If it's less than 120, it goes this way. So yes, goes this way. No, it goes this way. It then says rewrite the flowchart as a program in a language that you've been taught. Well, we've been taught Python, or most of us probably have, so we're going to do that. Now it doesn't say enter number of minutes played, so let's just put mins equals, gotta ignore the option that Adobe's given me, equals input, how, add on enter, number of minutes played. Okay, done that. If it's bigger than that one, so if mins, because I was just called mins rather than minutes, it's bigger than 120, then we need to do, if it's yes, we need to print the message they've given us by the example, which is you played games for too long, exclamation mark. Not too long, too long. Else, that's the no part, you are under your time limit. Right, it says rewrite the program. So have we done this bit? Yep. Have we done that bit? Yep. Have we done that bit? Yep. Have we done that bit? Yep. Have we followed the exact same case? We have. We've done the exam paper, and we are there. Now, obviously, again, like I said, I'd go back and read through my exam questions, make sure I didn't make any daft mistakes like I, accidentally did in this one, and just double check and go through all the paper. But hopefully that's been useful for you as a run through of a Comp 2 paper. So like I said, on our website on smashyourexams.com, you can get knowledge organisers, and you can get tutoring if you need that in GCSE Computer Science or A-Level Computer Science. And at the top here is a little link to go back to the Comp 1 walkthrough if you've not watched it already. Thanks for watching, and we'll see you in the next one.